Hello and welcome back to DCJ Gaming. In today's video, I wanted to demo the procedural map generator I created, show you how to use it, and if you like it, help you implement it into your projects. This is specific for a flat 2D game. I'm making a game that's going to be kind of a combination of RimWorld and Factoria, and it's going to be tile based. So if your game's different than that, I think you can still find some value from the logic and then manipulate that to be more specific to your project. But if you're specifically building a 2D game, this should be perfect. And just to show what this looks like, it builds off of OnStart at least now, but you can see we're getting different generations. It's all procedural. I've also have some override logic in here where I was on the outside 6 tiles to be water, and then the inside 3 off of that to be, this beach like this. So I'll show you how to kind of do some overrides, right? Maybe you want to override some stuff in the middle, so it's always there. And then the rest of this is just always procedural, but we have some logic behind it, so it's not just completely random. Right, I'm trying to get forest tiles to be spawning by forest tiles, which is this dark green. And then lighter green grasslands and deserts. So as you can see, it's you know random, but things are clustered, which gives it a more real feel. The scaling on this as well can really be pretty big. I have it 100 by 100 tiles, so 10,000 tiles. We kind of go in on and this game is very early development, but these are kind of the base of my character models, right? Comparatively, it's pretty big, and I think I can easily make this a lot more scalable. If we go to 1,000 by 1,000, that gets pretty big. But we are using static mesh instances, hierarchical, for the map tiles, so this comes with some efficiency. So without any further ado, I'm just going to do a quick intro, going through all the logic, what's going on, and then we'll go step by step. And get more into the details. All you need also for this tutorial is Unreal Engine, and then I'll be doing some stuff in Microsoft Excel, and we will be bringing in some CSV tables. You could do this manually without CSV tables coming in as data tables in the Unreal Engine, but I would recommend having Microsoft Excel for this, or at least the ability to create the CSVs and bring those in. And then the other piece, I'm using Blender just to make a very simple tile that I'm using. You could do this just with the generic plain tile that comes with Unreal Engine, but I recommend just building your own in Blender. Super simple, but just so you have better control over the UV wrapping and the size of the tile. So I'm actually going to pivot into Microsoft Excel, and you don't have to do anything I got in here, but this is where I kind of built the concept for the logic, and I just really kind of want to explain what's going on. So this is a table, 100 by 100, each of these cells representing one tile that will be spawning in Unreal Engine. Basically, the way the logic works is we're going to generate, well, every number 0 through 100 corresponds to a tile assignment, right? So as we look in here, if a tile has this number, it will be this type of terrain, right? Grass, water, forest, desert is what I'm using. It may be better shown here. These are the ranges. So water, any tile that is 50 will be water. Any tile that's 49 or 51 will be beach, right? And then these ranges going up through here. So my point of showing you this is, one, just to give you a little bit of a taste of how this is going to work, but two, also to show you just how customizable this is. So if you want different, you have several different terrain tiles, right? You can just add them into this logic like this. Right? If you want things more likely or less likely, you just change your ranges. So super customizable on what you're doing. Over here is kind of how the math works in Unreal Engine, maybe better visualized. So I'm manually hanking in 50s on the outside because a 50 value comes back as water, right? And I'm trying to make every map be on an island. So 50s on the outside, and then I have 49 and 51s, which are my beaches. So these are manual overrides that I load into Unreal Engine in an override table, which we'll get to. But I just kind of want to show you guys how this works, so that I always get the same pattern on the outside. It's always an island, but the inside is completely generated. The way the math works on the inside and what I'm doing in Unreal Engine is a little bit different than this, but basically we're getting either a -1 or a +1, and then we're getting a number between a range, and the range I have here is 0 to 10. So we get a random number between 0 and 10. We at random multiply that by 1 or -1 to make it positive or negative. And then we add that to the average of some of the adjacent tiles. So I'm getting the one above it, the one to the left, and the one up to the left, right? So maybe I can zoom in a little bit. And don't worry about any of this in Excel. I'm just doing this to kind of explain what the heck I've have come up with here. But so it's getting a random number between 0 and 10, which is customizable by you, right? The higher that range is, the more variability you get. The lower that range is, the less variability you get tile to tile. And then we're adding or subtracting that to the adjacent tiles. So what this does is it prevents a ton of variation, right? So for me, I want these kind of clusters of trees, right? This dark green will be forest tiles, and I'll have some trees spawn on there, right? This tan is desert, and this light green is grassland. We got a little bit of water in there. So if I make this, I can demo this in here. And again, like we'll get into all this, but if I make my min-max range even smaller, here's 25. If I move this down to 5, we should see even less, right, variation, right? So you can see these huge grasslands, right? A little bit of sprinkles of right, some other, because it's still some random, but more grouping. And then if you want it just super crazy, you can just expand this range, right? And now it's just a lot more variable. So just trying to show, I think I had this maybe at 10, kind of how this works. So in the way the logic works is we go, in my method, right, it's tile by tile, we'll be for looping an array which contains all of our tiles, but we'll be going top, down, and then left, right. So that's the reason I'm grabbing the adjacents. How I am is because everything, this is the cell that we'll be generating, everything to the right and everything below has not generated yet. So I'm grabbing these. Now I'm doing this a little bit different in Engine as I've tweaked it, but hopefully this is starting to make sense, right? So then depending on the random calculated value on my non-static overrides, that then returns a tile type. So if you think about this crazy Excel sheet table up here as what's going on in Unreal Engine, see every time we recalculate, we're getting random numbers over here, which are returning random, or not random, looked up terrain associated with that random value, and then that's what we'll generate our table off of. So hopefully that all makes sense. If it doesn't, just let me know in the comment section. And I really, actually, I should have mentioned this right away in the video, but I do have a Discord, great place to go to ask questions, get help with some of these tutorials, link in the description. That's the best way definitely to reach me and get help. So let's come back into, actually, before getting on Unreal Engine, just one thing quick I would recommend. This is Blender. This is the tile that I'm generating, right? I'm generating 10,000 of these because my tile or my map is 100 by 100. This is the tile that I'm spawning. Super simple. It's just, if you've never used Blender, it's free. Download it, do Control A, or no, not Control A, Shift A, mesh, plane, and I did mine 4 meters by 4 meters, right? You can do whatever and adjust the size in Unreal Engine, and then just export that and load it into Unreal Engine. But super, right, insanely low poly. It's only 4 verts. I really did this just so I have good control over the size, and then I'm unwrapping it to the texture I'm using for my map, just to make sure that it all scales right. Right, these are super, low poly, simple textures, but anyways, okay. So first things first, to start this, I would get rid of any landscape or anything you have in your map. As you can see with me, I just got some basic lighting. I got some of my pond blueprints, which really don't do anything. I got this random spear, and then some of my resources. But really, all you need is your lighting, and you don't want any landscape, and have everything else blank. So the first thing you need to do is create an actor class. So right-click, blueprint class, actor, and I already have mine. So I'm just going to delete this one, but call it BP map generator. So I'm just going to walk through what we're doing in here quick, and then we'll break it down. And let me actually, yeah, I don't have anything in the viewport. Okay, so these are hierarchical, I'm probably not pronouncing that right, but hierarchical instanced static meshes. So they're, and the way you can add these is, you can just search instanced. Yeah, so there's instanced static meshes, ISMs, and hierarchical. These do very similar things. Basically, you got three options with this. You generate all 10,000 tiles as standalone tiles, which means they all have to render, right, all that, which can be pretty expensive, at least initially. Or you do instanced, which means that every tile under this instance tile is all rendered at the same time, because it's, think of it as it's like a clone of each other. So that's what the ISM does. So it makes it a lot more efficient. So I have, what is this, 7 different ISMs, well, HISMs. Instead of generating 10,000 tiles and rendering all 10,000 of those individually, I'm only really rendering 7, and I'm kind of cloning it a total of 10,000 times. If that makes sense. The HISM is a little bit more expensive than the ISM, but it comes with some more efficiency when you scale up and get bigger, because I'm not a complete expert on this, but as I understand it, when you're trying to call or do LODs, right, hide some of the stuff that's really far away, the ISM is all lumped in together as one. So if you got some tiles on the other side of the map that ideally would be called, or a smaller LOD, you can't do that because you're still looking at the tiles that are under that ISM close to you. The hierarchical, you can set some more settings so that it does segregate those bunches a little bit, if that makes sense. So I think the HISM is worth it, especially if you're going to have a pretty big map. And this one's not huge, but we still have 10,000 tiles, and then I'm going to be putting some actor resources over the top. So I think that's a good way to do it. So to start, you should bring in your tile, which I have here, and then I made some materials, instances of this mesh material, which I'm not going to go through here. If you want me to go through the materials and kind of follow a video, I'll do that, but I'm going to keep this to the generation. So tile, materials, and then just add a hierarchical instance static mesh, and have its static mesh be your tile that you brought in, and then have its material be the instances. So I have a grass one, a beach, a forest, a desert, water, beach, a couple different beach ones. And right, again, this is really scalable because, right, I have this material called grass 1. At some point, I'll have like a grass 2, a grass 3, just for some variation. And I'll just create new HISMs for those, and then just build them into the logic. But it makes it really scalable. So start there, new actor class, HISMs. So just kind of walking through the logic off of our event begin play, I'm running this custom event called build map, right? And then I have all these functions that I'm running after. I'm going to go through these quick, and I'll come back through each one. But the generate map, this is where I'm saying this is how big I want my map to be. So map width of 100, map height of 100. And then we're doing a bunch of loops to generate each individual tile, and give it its coordinates. And then a unique tile ID, and with those coordinates, we'll then calculate a spawn location for that tile. I'm also doing a function in here where I load overrides. So instead, like in this example, where Ooh, uh, ignore this. This is a bug in my Excel, but these should be beaches. But over here, regardless of how many times I run this, these are always water and these are always beaches. That's because I am telling Unreal Engine for these specific tiles, don't generate a value for them. Load in a static value. And I'll just kind of pull that up quick, show you what that looks like. Super simple. It's just a really simple CSV. Tile overrides. All right, so it's just the tile ID, the generated value I want it to be, and what its train would be. Right, so you can see everything in here is just water and then some different shore. And rotation, which you don't have to worry about in this video. So that's what we're doing in this generate tiles function. And then this calculate terrain, this is where I'm taking some of the logic that I showed you in Excel and trying to do that here. So we're grabbing all of the tiles we've created that haven't been spawned yet. We just know they're going to exist. And we're grabbing, through this logic, the adjacent tiles to that tile, and then getting that average. So we're getting the average of the tiles that have already been created that are adjacent to this new tile we're looking at. And since this is a loop, right, this is going one by one. And then we're getting a random number of 1 or -1, because sometimes we want to add to the average, sometimes we want to take away from it. And then we're getting a random number in between 0 and 10, right? Which you can do whatever you want. Again, the bigger you make this range, the more variability you get. The smaller you make the range, the less. Multiplying that by either +1 or -1, and then we're adding that. Get rid of this, and we're adding that to the average of these adjacent tiles, which I'm pulling in 7 adjacents, which I'll explain. This clamp is really important. We'll get to that, but I only have lookups between 0 and 100, so I always need my new generated value to be 0 to 100. Again, if we come back into Excel, right, these numbers are always 0 to 100, because that's what this lookup table, which loads in, looks at. So hopefully that makes sense. Then we generate a new calculated value, and then we add that into the structure, which we'll create. So calculating that number, I'm going to unplug this for now. We'll come back to this recalc. And then based off that number, I'll show you what this data table looks like. This table is just based off the calculated value, what terrain should it be, right? So it's just a table 0 to 100. Each number has a terrain type. So all we're doing in this logic is for each of our tiles, find the generated value, which is an integer, in this table, which I have as a map here, and return the terrain type, which is an enumeration, and then add that back into the tile map. So this is where we say, so we're calculating what the random value should be, and we're saying, well, that value now equals whatever terrain we want it to be. This adjustment we'll come back to. And then we add that tile actually to the map. So we have our map generator actor. Default Z, because this is 2D, right? So there's nothing up or down, it's just X and Y. But for each of these, I'm doing some default rotation, but we are setting the spawn coordinates, and then based off the terrain enumeration is the type of instance we want to create from our HISMs, right? So grass, forest, water, desert, beach, shore, and shore sea. So hopefully this concept kind of makes sense on what we're trying to do, right? Generate the tiles. Initially, right, the background of the tiles, not in the map yet, but just generate the map of them, calculate a random value, figure out what terrain that random value is associated with, and then actually create those tiles as instances into our map, right? And then this is the final product we get. So where to begin? You should have your map generator actor created, and take some time, create your HISMs for all the different terrain types. Right, if it's your first time doing this, this feels a little overwhelming. Keep it simple. Right, do grass, forest, and water or something. No need to complicate it. Next, let's create an enumeration. So right-click, blueprints, enumeration, and call it whatever you want, but I called mine e-tile type. This is my terrain type. So in here, you want to list all of the different types of terrain that your tiles could be, right? So I got grass, I got forest, I got water, I got desert, beach, a couple different shore ones, which I don't know if you guys care or not, but this is beach, this is shore, right? So this texture, I kind of gradiated it or made it a gradient, just so that the part by the water right, was a little bit darker, and then I had those manual rotations in here so that it goes all the way around. So that's why I have several different beach and shore, and not as much for the other types, but I'll add those later. So make that enumeration. And then right click, create or go under blueprint and do a structure and call this S-tile data. So for every tile, it has its own structure of information that we'll be using for our calculations and for our spawning. So open up that structure, and the first variable you want to add should be an integer. Call that tile ID. So every tile has its own unique identifier, right? 1, 2, 3, all the way to 10,000, or however big you make your map. This is important for getting some of our adjacent tiles. This coordinate variable, I don't think I'm actually using it. You probably don't need it, but if for whatever reason you want to get the tile name or the tile ID is, it's unique in sequence. The coordinate is kind of where it is on the map, so you can probably skip it, but if you want, it's just a vector 2D. This gen value is an important one, so I have that variable. Integer is very important. I would not recommend floats because all of our logic derives off of calculating a round numbered integer and then returning its terrain type. Floats, right, have several decimals, so that becomes really hard in this method. So make this gen value an integer. Generated, this is a Boolean. This is important because we use it for determining if we should recalculate a new random generated value or not, or use the override basically. So have this generated Boolean in. Tile type, new variable, this is a key one. This should go back to your enumeration, right? So e-tile type for me, that's what this variable should be. This last one, I'll hit this at the end, rotation. So if you care about rotation and forcing specific rotations for specific tiles, then create this as a float. But this isn't mandatory for this procedural generation. Okay. After you have that, let's create two more structures. So right-click, blueprint structure. Call this one S-tiles overrides. This structure and the next structure, we will be creating to load our data tables. So this one, right, pretty simple, but one variable integer, the generated value. Next is the terrain, e-tile type, and then rotation, if you care about rotation, and overriding, right, forcing a certain rotation, then add that in as a float. And what this looks like is this. So you might be thinking, well, how do you know what tile should be getting this specific override? I'm doing that based off the row name. So each row name is the tile ID, which we'll be grabbing from our tile data. We'll load this data table next, but let's finish up our structures. So once you have this tile override structure, next is, I don't like my naming convention here. There. So create under blueprint structure, and I call this one tile val ter. It's tile value terrain lookup is really what this one is. Just abbreviating it so it doesn't take up a whole lot of space. But call it whatever you want. But what this structure will be is which random integer we calculate, which terrain it should be. So call that what you will. A really simple structure. Just have a value as an integer as one of your variables, and then next your tile type, which I'm calling terrain, and that should be of this type enumeration. So e-tile type for me. And right again, what this will look like is just my row name and my value are the same. I could probably get rid of value, but it doesn't matter. I'm actually looking up based off the row name, I think. And then the terrain that calculated value corresponds with. So once you have these structures, these two we will be creating data tables for. So to do that, let's create our first data table, and let's do our tile value terrain. So right click, go to miscellaneous, and then data table. And now when you pick your structure, pick style var. Let's see, where is it? style. There. style var terrain, whatever you called it, the lookup. I'm going to cancel this because I already have it. Yours will be blank, but now we'll do the work of actually creating the CSV. So let's go back into Excel. So you got to figure out, right? Don't worry about all this noise I have going on here in Excel. But what you need to figure out is what numbers do you want to correspond to which terrain. My method, I'm doing 0 to 100. I think start there. Right, follow along with me on that. And then as you get more familiar with the system, you can edit it. So what you need, right, is just a list, right? So start with a list of 0 all the way to 100. Right, and then next you need to start deciding which, and this is just numbers, right? But which numbers do you want to correspond with which kind of terrain? What's really important as you're building this out is the text that you have here, and I have an Excel lookup, but don't worry about it for right now. The text that your tile is must be an exact copy to these enumerations, right? So if you spell grass wrong in your Excel sheet and then load that in, and you're missing an S, it's not going to load correctly. So make sure you have this perfect. Now, as you're kind of thinking about this, I'll show you how to make the CSV. I'll show you how to load it. But what I want you to kind of think about is it's all about probability. And my logic really kind of starts at 50, right? Which is right in the middle. Zoom in a little bit. So 50 is my water, and water does not spawn very often, right? We can see it does, but it has to be 50 out of, right, all of the random numbers I can calculate between 0 and 100. Every time it's a 50, it's water, right? So very infrequent. You can see down here, right, outside of this outside, right, 3% of my tiles are water, right? So really infrequent. It's because water is only available on the calculated value of 50. Right, versus forest and grass are calculating 62% and 30% of the time. Why is that? Well, I have forest being 20 to 39, and I have grass being, well, actually I have forest 20 to 39, and over here 52 to 71, and then I have grass 40 to 48, and 72 and 80. The reason I did it this way, like going up and down, is because we're determining if we're determining a negative or a positive number logic, right? So our first thing is it a positive one or a negative one, and then multiply that by our random number in a range of 0 to 10, or whatever we specify it as, plus the average of the adjacent tiles, right, to get some smoothing. So sometimes, maybe let me show over here in the calculations, right? Sometimes we're generating higher numbers and lower numbers. So I don't want the like right both of these just to be grass or all this to be grass and then all of this to be forest, right? Like I want some variety in there, whether we go trend up from 50 or lower than 50. Hopefully that makes sense, but think of water as your middle, at least for me, and then I want to have everything on the outside. But my highest probability items, for me, it's going to be the forest, right? Because here it has a range of 19, here it has a range of 19. So as you see it in here, right, we have a lot of forest, and a lot of forest over here. Grass is the second most frequent, right? Because I have grass coming in from 72 to 80, and 40 and 48. So less, right? So 16 occurrences of grass in that list versus 38 for forest. So not as likely as the forest, but it's still fairly likely. Now, desert has a wide range, um, but it's on the outside of my calculation, right? So the logic starts at 50, right? And then we're getting a random number, 0 to 10, right? Plusing or minusing it. And then, right, sometimes it gets out of control. But generally, right, like as you kind of look at the calculations, right, we have some in the 70s, right, we got an 82. We'll get some low numbers, right, like a 27. But these these ones on the end, right, these are outliers. So these are my really my less frequent, right? Like we're only hitting desert 5% of the time, 2%, 3%, this time 1%. Now, if I want more desert, right, I would just, right, give desert, right, if I go like this, now it's 0 to 34. Right now we see desert, right, spawning a lot more. So super customizable system. I don't want a lot of deserts. That's why I have it this way. So hopefully this makes sense. But think about now as you construct this lookup table, right? All you need 0 through 100. Don't worry about this abbreviation or this single. Just this and this. So do that now, 0 through 100. Um, and then list out what you want for each number. So how do we actually get this into Unreal Engine? So the easiest way to create a CSV is just create an Excel sheet. And this is pretty important in here. So let's go back to Unreal Engine and let's go to our structure. So we're starting with this tile, val, terrain. We have val, V-A-L, and terrain, T-E-R-R-A-I-N. So your headers, for your columns need to be exact matches, to this. So start, and actually you got one thing in front too. So the first thing in A1 in this new Excel sheet, you should type row name. B1 would be your first variable, val, needs to be an exact match. And then C1, terrain. Okay. Then simply, right, if you got your list in here, grab it, copy it. If you are running any calculations, just make sure you paste this as a value. And yours probably pasted like this, right? Your value and your row name should be the same. So take this, cut it, paste it over here, go like this. That's what I'm saying. I don't know if we need the value, but it's fine. So now you should have a list, row name, value, these being the same, 0 through 100. And then in your seed column, you should have the terrain enumeration that you want corresponding with this tile. Then file, save as, colony sim. So in my folder for the game I'm making, I got a tables. But as your save as type, save that as a CSV, comma, delimited. And then I just called mine DT tile value terrain. So save that. I'm not going to save it. I already have one. I'll pull that up again. That's my overrides. So here's mine. This is what you should have. So when we come back into Unreal Engine, you probably have this blank table, but hit re-import, and um, it should, so I've already got mine linked, but it should pull up a file explorer and then just select your file and then load it in. If you're having errors, it's likely because your headers aren't exact matches here and here. So this should be row name, value, terrain, should be exact text matches, or your terrain type, which is of type enumeration that we created, needs to be a perfect match as well. Okay, so hopefully you guys are following me so far. This will all start to make sense when we get into logic, hopefully. So I'm going to close the enumeration. I'm going to close this data table. I'm going to close this structure. Yeah, we'll do overrides. You might not care about overrides, right? Again, what the overrides are doing is it's forcing water on the outside, beach in between that, and then random everywhere else. Right? If you just want a sheet of tiles, it's completely random. You don't need to do this. But nonetheless, I'll show you how to do it. Right? And if you want like I don't know, a temple in the middle or something, whatever it is, or a swamp or a desert, always in the middle, this is the method that you would do to do that. So you should have your S-tile override structure. Should be a gen value integer, should be your terrain type, rotation float, if you want it. So right click, miscellaneous, create your data table, have that be of your override structure. Okay. And so DT, I don't know why my naming convention's so weird. There we go. Okay, so DT tile overrides. So to create this, it's not as complicated as it probably looks, right? All it really is this row name is the tile ID. So this can get pretty annoying to map out, right? Because there's 10,000 tiles. Now, I don't have 10,000 tiles in here. I only have the tiles I'm forcing, which is 2,945. So the way this works when you're thinking about your map, and it's kind of why I charted it out like this in Excel, is maybe, yeah. So this is tile 1, this is tile 2, this is tile 3, this is tile 101, right? Because we come all the way down, this is tile 100. So the way this generates is top left, or top, down, left, right, right? So we will generate the map like this, and then like this, and then like this, and so on. And I have that reflected. These are gen values. Yeah, over here. So let's just bring this up a little bit. All right, so you can just kind of see the tiles, right? What their number will be. So if you want like the middle of your map to always be deserts, right? That would probably be, right, these kind of 4,000 numbers would need overrides for saying force this to be a desert every single time. So take some time to think about how you want to do that on your side, or if you really even want to. But all you need to do is create a new Excel sheet, save it as a CSV. I call mine DT tile overrides. And all it is the row name is your tile ID. So let's pull this structure back up actually. So we have our tile overrides. When you load an Excel sheet or a CSV into Unreal Engine, your first column must be row name. So start there. And then again, just like we did before, make sure these columns are exact matches to these variables: gen value, terrain, rotation, which I'll explain rotation at the end. If you have it, that's fine. You can just leave it blank in your CSV. So the generated value, technically, actually, it is important. So you might be saying, well, if I'm telling it what terrain type to be, why do I need the generated value? because we will be doing logic off of these tiles if they are adjacent to tiles being calculated. So if you just have a junk number in here, that will really screw up. So you should have a generated value that makes sense for the terrain type, right? So for me, come back in, water can only spawn if its value is 50, right? So 50. So in my override table, I need my water tiles to have a gen value of 50 and then say 50. And this is mostly for the procedural calculation part, but it is important that your generated value makes sense to what the terrain is. I have a lot in here because I have a big ocean around it, right? But then my shores, right, 49, 51. I'm saying what kind it should be, shore C, shore, or it's in beach. So yeah, make sure you do that, and then save that as a CSV, and then import that into this data table. Again, if you have errors, it's likely because your column names don't match this perfectly, or you have an issue with your terrain enumeration not being spelled correctly in your data table. Okay, so hopefully that's clear. So now you should have tile data structure, you should have tile overrides, you should have a tile value terrain lookup structure, and then you should have data tables for table overrides, or for tile overrides, and for your tile value terrain. So let's go back into our BP map generator. I'm going to close this structure. I don't need this. I'm going to leave this tile data one up, and I'm going to reopen this one. Okay, so I'm going to follow along with you guys. I've already got the logic built out, but I'm just going to just go like this. I'm just going to move this out of the way. Okay, so, and I'll close out of these. So first things first, you should have a begin play by default, and you should have already created your HISMs. Create a custom event, build map, I'm calling it, and have that run off of your begin play. All right, so now when we simulate, nothing happens. So the first function, I'm doing this in functions just to kind of keep things clean. First function you should create, so functions, add a new one. We will call this generate tiles. I'm just going to put a 1 at the end of mine. This off screen, just because obviously I already have one. So we're going to need a couple variables, which I already have. So first variable, add a variable, make it of type integer, and call it your map width. And then you can just duplicate that and do map height. So I have both of mine set to 100 by 100. What that means, and I can't show it anymore, but I'm going to be creating 100 tiles down, 100 tiles across, and everything in between. So I have a, it won't be a perimeter. Why am I blanking? It's 100 by 100, right? So 10,000 tiles is what I'm creating, right? If you want to do 200, feel free to do so. Right? If you want to do less, feel free to do so. This is part of the customization that comes with this approach. So 100 by 100, 2 integers. Next, create a float and call this tile size. I'm sure there's somebody in the comment section can probably explain. I think it's Blender, right? This is 4 meters by 4 meters. But Unreal Engine units might be centimeters. I don't know. All I know is because my Blender tile is 4 by 4 meters, that equals a tile size of 400 in Unreal Engine. I don't think that makes sense with centimeters. Is it 100 centimeters per meter? Yeah. Yes, I guess that, I don't know. I guess that does make sense. I'm American, so metric system, I don't know, even though it's a lot simpler than ours. But if you followed me in Blender and you got a 4 by 4 plane, use a tile size of 400. If you're doing your own custom tile size, then you might have to play around with this to get it right. Next variable we need to add, and this is an important one, this is a map type. So maybe I'll just demo this, how you add a map, but since maybe it's not always that common, so new variable, call it tile map. But for this first variable type, do of type integer, and then next to it, instead of a single variable, do a map. And what we want this mapped to is our style data, right? Which is this. So I'm going to delete this. So you should have something that looks like this. What this is doing, right, is each tile has its own tile ID, right? 0, 1, 2, 3, 4. Actually, I don't think I start with 0. I think I start with 1, 2, 3, 4, and then all the way to 10,000. Every tile has its own tile ID. Then each tile needs its own pieces of data, which we're housing in this tile data structure. So this is just creating this lookup of this tile ID. Here's its structural data. And then we can pull that. So this map is really important. And the last main variable we need is the terrain map. So this one, a map again, starting with integer, but the other piece of the map, though, the key, no, this is the key, the value of the map would be our tile type, right, which is that enumeration of the type of terrain or tile we can have, right? So what this is really going to be reflecting is this table. Basically, and I'll show you how we do this, but we load this table and then we save the table into this terrain map. The reason I'm doing that is then we're initially loading it via the table, but then I'm storing it in this map so that we're not constantly reloading the data table for every single tile. I think this is probably more efficient to do it this way, so that's why I'm doing it. Okay, so come back in now to our function generate tiles. First thing we need to do is add a for loop. And this is important, a for loop, not for each loop, for loop. And then plug this in. So our first integer will be 0, and our last integer will be our maximum width. So let's bring our max width and subtract this by 1, and then plug this into our last index. Why are we doing this? Because I want 100 tiles across, right? Width of 100 tiles. We're starting at 0. I could start at 1 and then not do this, or I can just start at 0 like it wants to, and then -1. Basically, if you start at 0 and then just plug this in, you're actually going to do 101 tiles, because you have 0, and then 1, then 2, then 3, all the way to 101. So I'm doing it this way. This is just how I did it, and this works just fine. So first index 0, then map with -1. I'm going to create 2 local variables in here, just of a single integer type. First one we call x vector, and I'm going to control D duplicate that, and then we will do y vector. So this is the coordinates of the map, or of the tile across the map, which I'm going to come back into this crazy Excel sheet again, but right here are the coordinates, right, for each of these tiles on the map. Basically, we're going to take these, multiply it by the size of the tile, and then get its spawn location. So this is important. You might also use it for some other purposes. So we're doing our width first. So let's come in here, set, and come off this index and add 1. The reason we're doing this is, again, this loop is starting at 0. I probably could have done this differently, but this loop starts at 0, but I want my tiles to start at, right, my tiles to start at 1, be 1 through 100, not 0 through 99 for 100 tiles. So this just gets this first one set to 1, because the first time this runs, it'll be 0, 0 plus 1 equals 1. Hopefully that makes sense. Okay, then we can copy this for loop and do another one. Plug this in, and I'm going to steal this +1 and this -1. Just bring these over here. So this will look really similar. And plug this into our last. But now, instead of our map width, we're going to do our map height. Then grab our y vector, set here and here. So basically, how this works is we're going to run this loop 100 times, right? Because our map height or width is 100. We're also going to run this loop 100 times for every time we run this loop. And so just the thing for you to really picture in your head is we will create the tiles going up, down, left, right, right? Because we're starting with our width, we're starting with this first column, but then we're going down first. And then we're going here, then we're going here, then we're going here. So that's what this is doing. And when it's all said and done, we'll have run through this 100 times, we'll have run through this 10,000 times for each of our tiles. Okay, we're going to add another local variable. And this one's just going to be called counter. And actually, why am I even doing this? I don't even think I need this. 1 second. Look at mine. Yeah, we don't need this. I have no idea. Okay, just rename it F2 instead of counter. Call it tile ID. By default, have this start at 1. So what we're doing is every time we run this loop, right, I want to increase this tile ID by 1. And the objective is that every tile has its own unique tile ID that would range 1 through 10,000. So to do that, drag this in, get it, come off this, do increment, right, which is just adding 1, right? So you can also do add 1, but that's also what increment does. So grab your increment and then pull in your tile ID again, set it, and set it to here. So just to kind of demo what that's going on quick, I'll do a print string and plug this in. Oh, whoops, I forgot to do one thing. In our event graph under our build map, let's bring in our generate tiles. There we go. And when we look into our output log, come to the top. Right, so you can see these are our tiles. We're not quite generating them yet, right? But these are their tile IDs. So you should have something that looks like this, which is good. All right, let's come back in. Get rid of this. Okay. So then what we do, let's bring in our tile map. Get this. Right, by default, there should be nothing down here. Pull off this and do add. Connect this and connect this. So we're having the creation of our tiles from a kind of behind the scenes data standpoint. Now the structure is blank. So let's come off this and do make, and you should see your structure name, make s tile data. And then click this little arrow and then you get everything, right? And this should be everything that is in your structure. So then if you want some other random stuff, being a part of this, just add those as variables here, and those will come through to here. So first things first, we have our, local variables. We have our tile ID. So plug that in. There, that's weird. So plug that in here. Okay, off the coordinates, pull off this, do make vector 2D. So again, this is just its coordinate on the map, right? Which is like this. So the way to get this is we're setting this x vector and this y vector. So let's grab both of these, get them, plug this in here. It'll convert it to a float automatically. That's fine. Has to be a float for the vector. So I suppose we should probably do the Load overrides. Okay, we're gonna come back to this quick. Set this to 50. Leave this generated off, and you can leave this the default. We're gonna come back. This will load our overrides. One last thing you should add here is off of this first complete. Yeah, yep. It's important that's this first one. Definitely not this one. This one, pull off this and do a return node. So basically the way functions work, right, is when you call a function, right, like this, I have a bunch of functions lined up. When you call it, your execution can just continue on unless you put this return node in. Basically what this says is execution don't continue on until we hit this return node. And all I'm doing here is I'm saying don't hit the return node until we've completed all these loops. So this is important, or else your synchronization, your sequencing will get really out of whack really quickly. So be sure you have this return node. And we'll need these on all of our functions, but just good call out on functions overall. Okay, so I'm actually going to jump a couple steps, and I'm going to switch over to our add tiles, just so we can kind of start seeing this thing coming together. So let me move this out of the way. So let's do a new function, add tiles. Again, mine's going to be 1 because I have a duplicate. And what we're going to do here, so one of the first things I'm doing is I have a local variable. Sorry, 1 second. I think things have been screwed up because I bring this to another. One sec. Okay, there we go. I have both functions up, just so I got a kind of a reference to look at, and it's just kind of bugging out for whatever reason. So first one, do default is the and make that of type float, and you can make its default 0. So the reason I have this, and you really don't need this, and actually important call out here, especially if your print string wasn't working. Make sure you call in your BP map generator, or you drag it into the map. So here's the actor, bring it in. I should have, hopefully nobody got stuck on that. I have mine at a default location of 0, 0, and 50. The reason I did 50 is when it's at 0 and I'm simulating it, the tiles conflict with this grid array or overlay. It's just annoying to look at, so I just bumped it up a little bit. But yeah, you could do 0, 0, 0. But because I did this 50, this is why I added this in. So I want all my tiles, because this is a 2D map generation, to spawn at the same height, and then just spawn an X and Y. So when we spawn these tiles, we have to tell it where to spawn, and I always want it spawning at the same height as my actor. So the first thing I'm doing in this add tiles, I'm setting this default Z, and right click to get actor location. We can break this. So this is getting the world location of this map generator within our level. And we just take this Z, plug this in. So all this is doing, right, is if I move this from 50 to 100, then all my tiles will spawn at 100 instead of 50. And I'll have to remember to come in here and manually check it or change it or change my further downstream code. So hopefully that makes sense. Okay, next, let's grab our tile map, get. So a tile or a map it's really similar to arrays in some sense. So to kind of access it, because you can't do for each loop like you can array, you really have 2 arrays within it. You have your keys and your values. For us, our key is our integer and our values are the structures. when we're actually creating and adding our tiles, we want the values. So pull off it, grab values, plug that into the chain here. And now we can come off of this structures array and do for each loop. And because I don't want to forget off this complete, let's just do a return mode, as we should with functions. So now we have this array element, which is our structure. So let's pull off here, break it, hit this arrow to extend everything. So now we are getting the tile data for all 10,000 tiles. So we're doing 100 by 100. I have another local variable in here, so let's create that. This is Z rotation. So if you're not worried about rotation and you didn't follow along with that part, you don't need it. If you are, this is where we will apply it. I have my structure, I'm just plugging it in here. Right, so I have every tile can have its own rotation, and this is coming from my override, and it'll make sense next. So we got Z rotation. Okay, we need two more local variables. We need X location and float for that, and then Y location. So this is where we will be spawning the tile. Let's pull both of these quick in. With an Alt left drag, you pull them in automatically as set. If you do Control left drag, come in automatically as a get, right? Versus going like this and clicking. So this is where we want the tile to spawn, right? So the way we do that is, oh, okay, and we do need our coordinates. So if you didn't create the coordinate, because I wasn't sure if you need it, you do actually need it. So make sure you have coordinate in your structure, and then make sure in your generated tile values you have this. It's more important than I remember it being. So come off of this coordinate, and then do break. Start getting the X and Y coordinate. Now, our coordinates right now we are storing right as these kind of singular integers. But this isn't the world location we want it to spawn in, right? Because if we spawn things at like 1, 1, 2, 1, they'll all be overlapping because these tiles are a lot bigger than one Unreal Engine unit. So what we'll do is multiply them by the size. Now, what I also need to do is come off here and do a subtract. And we're going to subtract both of these by 1. Some of you that are kind of really understanding this, right, you'll probably find some ways to make this method more efficient, and this is probably one of them just with how I'm setting the coordinate. But the reason we're doing this is when we come all the way back into our generate tile, I want my coordinates to start at 1, 1, not to start at 0, 0. So I'm adding 1 from the loop, and so instead of the first tile ID being 0 and the first coordinates being 0, 0, I'm having them be 1 tile ID with coordinates of 1, 1. However, we do want our first tile to spawn at world location 0, 0, which is where our map generator is. So because our first coordinate would be 1, 1, it will spawn not at location 0, 0. So hopefully you're following me on that. If not, just trust me, this works and it makes sense if you're doing exactly what I'm doing. So take these break vectors -1. Then let's grab our tile size, Control F drag, and come off this and do multiply. And then plug in this. And then we can take this, copy paste, and this. Okay, so what this is doing is it's taking our coordinate, multiplying it by the size of the tile to then return where this tile should spawn at. So the first one will be 0, right? Because its coordinates would be 1, 1. We'd be minusing both by 1. This would be 0, 0, and 0 times anything is 0. But the next one will be 0, 1, which would then be 1 times 400. So it'll spawn at 0, 400. in the world, which is what we want because that's how big our tile is, and we want our tiles to be spaced out. So you can think of this tile size as also kind of the spacing. So let's plug this in. So continuing the chain, we'll set our X location as this and our Y location as this. Okay. And the next piece, we have this tile type. Come over here and do switch on eTile. So we're switching on our enumeration, and I'm just going to reroute this just by double clicking. Let's make it a little bit cleaner. So we're going to be setting this later, right? I'm having you guys just do this default, whatever's in here. For me, it's grass, gen value 50. But I just, right, we'll see the map, and then we'll add some logic in, and you'll be able to see it evolve since we're doing this. Okay, so this part's a little tedious, but it's important. So these should be all of the enumerations you see in here. And there's this little up-down arrow, so you might need to hit this to extend it. So what we're doing, right, is if the tile is grass, then we want to create a tile using our grass. So the way to do that is we grab our HISM, pull off this, and do add instance. Connect this in. And then off of our transform, we can make a vector. Or, no, sorry. Split this. Right click, split. Now we have location, rotation, scale. Scale should be 1, 1, 1. Location, we can make vector. Do this bottom one, not this quantitative or whatever that is. And get myself a little bit more space. Okay, so this is where we want it to spawn the world, right? When we got everything we need. So X location, plug that into the X. Y location, plug that into the Y. And then our default Z, right, which is coming from where our actor is. That's why this part was important. Plug that into here. Now, for some of these tiles, I have a forced rotation, but some of them I'm just doing a random rotation. And maybe let me just show you what I mean by that quickly. So let me just plug in my working logic. So, right, you can see these textures here. Maybe it's not that easy to really tell. Maybe you can see it a little bit, right? These are all the same texture, but they're rotated different. So they're randomly rotating just to give it like, you can kind of see here, right? It's just like, I don't know, just looks a little bit different, right? The water is like that too a little bit. Maybe it's hard to tell. Maybe this isn't that important, but I wanted things to just kind of rotate. So it just gives some inherent variation without me having to create several instance static meshes. So to do that, we'll create another function, and we will call this random. So rand tile rotation. Again, 1 for me. And this is a cool function. It'll be pure. So click the pure box if you don't know what that is. I'll show you when we're done writing it. Just gonna bring my reference over. So it's really simple, right? Tiles, my tiles are squares, right? So I only want them to rotate at 0, 45, 90, 270, and then back to 0, right? So that's always having a square edge, right? Think about rotating a square. You don't want it to rotate by 8 degrees, right? You want full turns. So to do that, we're going to get a random integer. So random integer in range. Now range will just be 0 to 3. 0 is a number, right? So you got 0, 1, 2, 3. That's 4 possible combinations. Right? If that doesn't make sense, you can also do 1 to 4. But I'll do 0 to 3. And then we will switch on int, and we'll add a pin for each of the numbers that can be selected. 0 through 3. So 0, 1, 2, 3. And then plug this in. And then I'm going to do a return node, and we'll add an output, and this output will be of type rotation. I think that's what it's. Rotator. Yeah, so do of type rotator. There we go. And we'll call this Z rotation. Okay, so you can copy and paste this 4 times. It's basically what we're saying. Let me just connect all these. So if it's a 0, I'm going to have 0, 0, 0. If it's a 1, I'm going to do 0, 0. No, I'm sorry. I said 45, 90, 270. We want 90, 180, 270, right, for our turns, right, in degrees. So 90 degrees, 180 degrees, 270 degrees, right? One more turn off 270 is 360, which is the same as 0. So we'll start at 0. From 0, 90, 180, 270. And again, make sure you have it marked as pure. So let's come back into our add tile. So for this grass, we can grab our random tile rotation. This is what pure is, right? You don't actually have to connect an execution into it. It just runs when something depends on it. You just plug that in here. So now, every time we spawn grass, we will have a random rotation. And before I add more logic, I think it's a good time. Let's do a test. So I'm going to event graph. So we should have this custom event, build map. Should have event begin play, build map, and then our first function generate tiles 1. Let's just rearrange these. Now let's grab our add tiles 1, plug that in. And I'm going to move this way over to the left because we're going to fill in a lot more functions between. But we should, I think, see things spawn. Boom. Now, it's all grass, right? Because we're not doing anything different, but you should be seeing this. Oh, and for what it's worth, I'm doing simulate, right? It's the same as if I just play, but I don't want to actually load in and look around. It's just a little bit quicker, so we're doing simulate. Right, and we can see with the rotations, this is a little bit better, right? You can see this is my grass texture. Right, it's just this kind of weird little gradient. But you can see each tile is rotating a little bit. Just give it a little bit of variation. So that's awesome. Let's come back in, and now we need to fill out the rest for off of our switches. So I'm going to copy and paste what I already have. Really, actually, maybe not. I won't. I'll go along with you guys. Pretty simple, right? I mean, you can copy and paste everything, and then you're just replacing your HISM with whatever's next. So I've got forest next, plug that in. Boom. After forest, we have water. And actually, I decided with my water not to do the random rotation. Choice is yours. You can or cannot. That's why we weren't seeing the variation I was showing you earlier. Okay, after water, we have desert. Desert, I'm also not doing rotation, just because of how my texture looks. Rotation doesn't work for it. After that, we have beach. Just the beach. I was doing random rotation, so I'll bring this in. Right, and these are all decisions you can make, right? What materials, what do you want to call them, whether you want them rotating randomly or not. That's all up to you. Okay, 2 more. Okay, so these next 2 are important if you care about controlling the rotation of some tiles. So, like I was saying earlier, I have beach tiles, but then I also have beach tiles that are on the shore, beach shore. And then I also have a beach shore C, which is the beach tile that is on the corner. So I want those to have very specific rotations because the dark part of that tile, the dark part of the sand, should always be closest to the water. Um, so the way we do that, Z rotation, it's default Z. Oh, yeah, we're getting it right here. So you should be setting this local variable of Z rotation. It's coming from our tile data, and we load this through our override table, which will be our next step. Setting this here, so instead of a random rotation for our shore tiles, at beach, I'm having be random, but these ones I want more controlled. I'm doing the Z rotation. So get, and actually off of this rotator, let's do make rotator, this bottom one, and then just plug this into the Z. Boom. Now we have manual control over the rotations for these instanced static meshes, which are my short ones. The rest are either random or I'm just not doing. Okay, now we won't see anything different when we come back into our generate because we're not actually setting these, but we've got the bones for what we want to do. Okay, so we can close add tiles. So we're generating our tile map and then we're adding them. What we want to do next is actually calculate and oh, actually no, sorry. We got to load our overrides. So add a new function, load overrides. One for me. Bring this off screen. Okay. So this is actually pretty simple. So you should have this data table, right? Loaded, working. So first thing, right click and do get data table row, right? There is a get data table row names, which is returning this array. We just want the row, just the singular row. The data table type will be our DT tile overrides. Let me plug this in here. And then coming out this row name, put this here. And we also want to make this cast pure, so pure. Okay, when we come off our out row, we can break this. This will give us the structure from our table, right? So our generated value, our terrain, and our rotation is coming in here. And again, that's coming from this structure. And this is where that rotation is coming in if you want it. Now, one reminder, what's really important about this data table is your row names equal what the tile ID is, which we are assigning here in the generate tiles, tile ID, right? Those need to be matches to return the right data. Okay, and we'll come off this row found, we'll do a return node, and then we'll just plug in generated value, terrain, and rotation. Now, this isn't something we should do too. Off the row not found, we just copy and paste the return node, plug this in. Okay, and then this is all fine, right? 0, grass, rotation. Click on the return node though, we need to add one more thing. So click add an output, and this will be of type Boolean, and we'll just call this found, question mark. So if we row found, check this true. Row not found, check this false. Okay, so that's it for this function. Let's come back into generate tiles. Okay, so where we want to then implement this is down here when we're making our structure. So let's grab our load overrides, pull that in. So you can see then these return nodes match perfectly for what we're missing. Our gen value, terrain type, rotation, and then we're going to plug this found into generated. what this basically means is if a tile's already been generated or found, quote unquote, then we're not going to calculate a value for it, right, procedurally, because it already has a value. So that's what this is doing. So for everything we find in the override table, it's generated. Don't calculate anything further for it. For all the falses, we need to calculate for it. Okay. Okay, so next, we need our row name. And again, your row name should be the tile ID. Now, rows, though, are always name variable types, which is fine. So we'll grab our tile ID. This is an integer. And I can't plug this directly in. But what I can do is I can do toString. So toString integer. And then from there, I can convert the string to a name. So just like this. And now this will provide our lookup of the table ID, and we'll see if we find it in this data table. And if we do, we'll grab the structural data, pass it through, and add it to this tile ID in this map. And if we don't, we'll just load some kind of generic, right, 0, grass, 0, not found, and then load it into the map. Hopefully you're following me. Now, if you have a data, now you don't need anything in here, right? This can just be completely blank, and if you're lost, you could just have nothing in here. You can build it just like this, and you can build out this logic later, and everything will just return false. That's fine. You can have this completely blank, or you can just skip this entirely and just fill in these with some defaults. But if you do have an override table, when we come back in and we simulate, you should see those overrides coming in. Right, so the middle is still all grass. It's still going to our defaults. But we have our water on the outside, we have our beach on the inside, which is how I want it, right? And as I was trying to explain with the rotation, so I'm talking about this is a corner beach, right? So that needs to be rotated different than this, right? And then this beach on the shore, right? I want the dark part by the water, needs to be rotated then over here. So that's why I have rotation in my override table, is so that I can control that. And that was kind of a trial and error figuring out what the right rotations were. Even though it's not that simple, for some reason I struggled with it. But yeah, so you should be at that part now. Let's come back into our event graph. So we have our generate tiles. 1 second, I just got to clean something up. Okay. So what do we want to do next? Now we want to actually start calculating the values for the non-generated. So add a new function. I'm just going to call this calc ter for terrain, val for values 1. Calc terrain values 1. And let's just go ahead and plug this in here. And then we can do this. Okay. And let me pull up my reference. Okay. So what we're going to be doing in here is this, right? Getting these random numbers, but not completely random, right? We want the numbers there to be variation, but we want things to be smooth, right? So that you're not going forest, grass, desert, right? It should be more likely that it's following along so that it's not super abrupt. At least that's what I'm trying to do. You can edit the variation if you want something different than that. So let's start first. Let's pull in our tile map, and then let's do our values, just like we did before. If you hold on F, left click, you can get a for each loop. Plug that in, plug that in. Okay, so we're going to come off this, we're going to break it. And I think we only need 2 things here. We need the tile ID and the generated. You can uncheck the rest. So first thing we want to check, do a branch, left click, is has this tile been generated? And actually, in between this, come off this generated and do not Boolean, and then plug that in. So again, where is this coming from? Well, if it's in our override table, we are saying yes, found. If it's not, we're saying no, not found. And that's setting this generated. So if it's in the override table, it will be generated. If it's not, it's not. We only want to calculate a new value and then a new terrain for the things that have not been generated. Okay, hopefully that makes sense. So this will start to tell us which tiles within these values array, looping one by one, we need to calculate a new value for. So the first thing, right, and again, this is the logic I came up with to do this. I want to get a random number, right, a plus or a minus, but I don't want this thing to just be super random. So I want to consider the values of some of the adjacent tiles so that it's more smooth, right? So as you can see, right, we have a 56, like it's not just going 0 to 100, right? Right, here's a cluster of higher numbers, right? So then those will be likely to be the same terrain types. Here's right here, we can see some lower numbers, right, in here, right? So then these are likely, right, here's a perfect example, right? Some really low numbers. So these will be the same terrain type. The point of this is like, I don't want a ton, like I want it to be random, I want it to be procedural, but I want there to be clusters of forests and clusters of grasslands and clusters of deserts together. So to do that, we need to start by getting our adjacent tables or tiles. And it's really simple to do that because every tile, come back down into here into our tile IDs, right, has its own tile ID. So if I want to get some of the adjacent tiles, and this is a really important point I keep making, right? Again, we start top down, then left, right. So when I say I want to get the adjacent tiles for tile 806, I can't get 909, 910, and 810 because we haven't generated a value for those tiles yet because we start here and work our way like this. So I can only grab the adjacents for anything above it or to the left of it. So what we're going to do in Unreal Engine, right, using tile 809 as an example, is we're going to get the value that's been calculated for 808, for 708, and 709, right? I'll show you guys later on in this video, actually what I'm doing for my game is I'm grabbing these, right, which is, it keeps things even just a little bit smoother, if that makes sense. But for this tutorial, at least to start, we're just going to do these three, and then it's easily modifiable. So how do we get that? How do we get the adjacents to factor into our calculation? So what we need is our tile ID. And coming back into here, right, tile ID 809, if I want to get the tile above it, I just have to subtract 1. 809 minus 1 equals tile 808, which is what's right above it. If I want to get in the column to the left, I go over 100. Now, this is because my tile size is 100 by 100. If you're doing 200, you need to go over 200, right, to go over a column. Hopefully that makes sense. If it doesn't yet, make your map size 100 by 100 and adjust it later when you understand this a little bit better. But because I have map width and height 100 to 100, then this is the applicable math for me. So here's what we're going to do. Come off tile ID, and I'm going to do a subtract, and I will do a subtract of 101, right? And so what that will do is we'll go minus 100, right? It's straight left, one column over. Minus 1 is 1 up. So 101 gets me this back diagonal one. Okay? Copy and paste this. I'm going to do minus 100, right? Which is just straight to the left. Then I'm also going to do minus 1. And just kind of go like this. Boom. Boom. And we can compile that. Okay. Now, let's grab our tile map. Pull off this and type find. So now, right, we want to find the tile data for this tile ID, right, that we're calculating. So copy and paste this. And copy and paste this. Okay. And then we come off this, break. And actually, and the only thing we need, you can hit this hide, the only thing we need is the gen value. Gen value, gen value, gen value. Okay. So now we want to average these. And there's a good way to average these that makes this a little more scalable than just adding them and dividing by the count. I take this and do make array. Then we can add 2 more pins. Plug this in, plug this in, and then pull off this and do average. So we get the average of all of the integers in the array. The reason I'm doing this way, right, if we want to add more adjacents, we just add more pins and do this, right? So super easy. Now, this is an important step, and it was screwing me up for the longest time when I was doing it. I couldn't figure out why. This is a float, right? And we need these to always be integers. There exists a function called truncate. And a lot of times when you're trying to convert a float to an integer, it will use truncate. The problem with truncate is truncate always rounds down. So come off this and just make sure you are doing round. Do not use truncate here. It's hard to explain, but basically, like because it's always rounding down, your long-term, your kind of working average as you go through the iterations is incrementally going down, 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 down. So then at the end, it's always the lower values in your range. Probably doesn't make any sense. Just do round. Caused me a lot of headaches. Okay, so now we have our average of our adjacent tiles. So this will be part of our calculation, but it's only half. This next part, though, is a little bit simpler. So again, we're finding the tiles that we have not generated a value for. So what we want to do here next is the first part of the math. I keep coming back to Excel. I don't know if this makes any sense to you guys watching, but hopefully it does. Basically what we're doing, right, is we're getting a random number. I'm doing between 0 and 10. Adding that to our average. But I don't always want to add it, right? Because the water starts at 50 for me. So if we keep adding, eventually we get to 100, which is my max. So I need to sometimes add to the average and sometimes minus to it. And I want that to be random. Right? It's part of the procedural piece of this. So the first thing we need to decide is this going to be a positive or a negative number? So right click and do select int. We have 2 options. First one, 1. Option A. Option B, -1. Now, there's this Boolean here for the select. Pick A, drag out this, do random bool. So this will just randomly, right, in the description, returns a uniformly distributed random bool. So it'll randomly either pick A or B, which will return a 1 or a -1. So move this up a little bit. So we're going to come off this and we're going to multiply. What we're going to multiply it by is what we want our random number to be. So I think I do this via locals. Yes. Okay. So let's create a local variable. Let's do of type integer. I'm going to call this min. I got 2 things up at once, so it gets a little weird. So I'm just going to do min val, right? And then I'm going to add another one of type integer. I will do max val. And for me, I want to do my min of 0 and my max of 10. So what do these numbers mean? Right, my numbers can range 0 to 100, right? And again, depending on that number, it will return a designated terrain type. I'm doing my logic 0 to 10. So what that means is any given tile, right, based off the average of the others. So here's a good example, right? It can be plus or minus up to 10, somewhere between 0 and 10 from the average of this, right? So the average of these 3 is 50, and this is 57. So what this means is it calculated a positive number A positive 1 multiplied by a 7 equals 7, and then it added that to the average, right? But when we run this a couple times, right here it's lower, so then it was a negative, right? A negative 8 in this case, right? So it's just the range of probability. Well, the range of the impact, I guess, right? If I make this way bigger, right, you can just see, right, this gets really variable, still random, right, still procedural, but just complete and utter madness. So I use 1 to 10 because it would give me something that's more uniform, right? Again, right, I want forests together, I want some open grassland, right? I want some desert tiles together, right? I don't want this just crazy random, right? I want things to be kind of grouped together. So 0 to 10 is a number I've liked so far, but you can do whatever you want. So we have the min, we have the max. So let's get both of these, get. Then we're going to come off this, we're going to do random integer in range. So we're getting a random number between 0 and 10. And then we're going to multiply that number by either positive 1 or negative 1. And then we're going to add, operators, add this to our rounded average of the adjacent tiles. Now, this next part is really important. My number of values can range from 0 to 100. So we need to do something called a clamp. So pull off this, do clamp, min 0, max 100. Now, you can have more iterations if you want. You just need to make sure that you adjust your table overrides, the generated values, right? If you want to do like 0 to 1,000 in your gens, and then your tile value terrain lookup, right, needs to be encompassing of your entire range. If you don't know really what that means or you're not following along, then keep it 0 to 100. Okay, we're going to create another local variable. I'm going to call this calc. So let's set this and then plug this return value into here. So this will be the calculated value from this math, right? From taking the average plus or minus a number random between 0 and 10. So we're calculating the number we want this tile to be associated with. Now we need to add it back into our map and tell the map what its new value is. So just pull in our tile map. First thing we got to do is we got to find. So we want to find the tile we're talking about in our map, which comes from our tile ID. So I'm just going to do this. Bring this all the way over. And I think, yeah, okay. So we find this tile's structure, and we need to set members. And what we're going to set is the generated value. Put this in here. And this is going to be set from our calc. And then this is another equally important step. Let's take this tile map again, do add. And we got to add this structure back into our map. Now, this structure already exists in the map. And don't forget about this key. The key would be our tile ID. So let me just steal this. So this key already exists in this map, right? But we're basically overriding it to this new structure. And the only thing we're changing in this structure is the generated value. So hopefully that makes sense. We're not really adding it to the map. We're really overriding the existing one because it's already in there. Okay. And last piece of business here off of our completed. Let's do a return node. Now back to the event graph. I think, yeah, okay. We should have this plugged in. Actually, plug it in. So generate your tiles, then calc your tiles. Oh, yeah. This isn't going to do anything yet because we just have numbers. So, right, we can go back, we can test. Nothing different. So, what we need to do next then is create a new function. and this will be called assign terrain. Assign terrain. And for me, pull this up. Okay. So what this function is going to do is just plug it into our chain right now. This function will assign the calculated value to the appropriate terrain type. So let's come in here. So the first piece I do here, right, we have this data table tile value terrain, right? It's our lookup. This integer equals this terrain type. I don't want to load this table for all 10,000 records or tiles. So what I do here first is I get data table rows or row names. And I want this data table to be my DT tile. It's just weird. DT. Oh, because I have till. DT tile. I'll come back. I just want to fix this. DT tile value terrain. Good. Okay. And then F left click for each loop. Grab this. Grab this. Okay. And then we got to do get data table row. So this is the unique row. Plug this array element into here. So basically what it's doing is just getting all the rows from the data table, and then we're going to get the data for each individual row within this table. And the reason I use data tables is just, or CSV data tables, like you can make data tables in here and manually add rows if you want, and then type all this out, right? Like you can change this in here now, but that gets super tedious with 10,000 tiles. Well, I guess we're not loading in, but this is 100, right? I'd have to hand type 100 of these, which you can do if you want, but that's why I use CSV tables. Just makes it a little bit more, way more efficient, just to do it in Excel and then load it in. So that's why I do this. You could do this like through a series of branches, you know, if less than this, but again, that gets really tedious to adjust versus just making changes in Excel and loading it in. So that's why I do it this way. But several ways to skin a cat, I think is the saying. Okay, let's just come off this and break it. And now we have this ter map, right, which we haven't done anything with. Terrain map is what this is. So let's get that, do an add. If the row is found, add it. We're going to add it by the value, which is an integer, and then the terrain. All right, so we're really just saving a copy of this data table. That's really all we're doing. But then I don't have to load the table over and over. I can just look it up in this map. So that's why I do this. So we do this, and then off of this complete, we're actually going to run the logic of doing our assign terrain. You could do this in a different function if you want, but I just didn't think it was needed. So let's first grab our tile map, get it, get your values, okay, and then left click F, or F left click for each loop. So getting all of our tile data again. We'll come off this, we'll break it. And the only things I care about in here are the gen value in generated again. So just like before, come off our generated, do not boolean. Left click B, or B left click for branch. Plugging this not. So we only want to do the things that we have not generated yet. Yes, we calced for them, but these have still not been generated yet, at least for how we're applying logic. So all those will still flow through to here. And then what we're going to do, grab our terrain map, get it. Just going to drag this up, pull off this and do a find. And what we want to find is our generator value. And this is, again, why this is important. This is an integer, not a float, because we need exact matches, and floats have decimals, and that makes that really, really hard. So find the integer and return its terrain enumeration. And then just like before, we can come off this array element and do set members. Drag this over here, and what we want to set is our tile type. Here, here, and plug this in. Okay, so now we're setting the tile. And then just like before, we need to get our tile map and add it back in. I suppose we can grab our tile ID from here. So check on the tile ID and just run this over here. And then make sure you connect this structure out into the add. And then off of this bottom for each loop, you can do a return node. I can't stress enough, make sure for all your functions you got these return nodes in the correct places and they exist, just so things sequence quickly. Just come back to our event graph. This is plugged in, get the assigned terrain, add tiles. Okay, this should work. Beautiful. So yeah, hopefully you're seeing this, right? If you're not, go back through parts of the video that we missed. But one thing to check is just make sure you have different materials set in your instanced static meshes, right? If you don't have different tiles, then they'll all look the same. But yeah, so as you run this a couple times, here's a streak of desert there. Run it again. Right, now there's some desert over there. Run it again, right? A little bit more sporadic, right? And this is where the customization comes in. So, if that was too dramatic for you, or you can come in here, you could change this max to a 5, right? Now it's a lot more uniform, right? It's still variation, right? But it's yeah, not as crazy as before. Now, what happens though in these cases, where you can see, I don't know if we have any desert. So, and this is what I was talking about with how I had this, right? I have the desert on the outside. They're the extremes, right? The lowest and the highest get desert. I'm just not, right? When I'm using a 5 and using the averages, I just don't touch those extremes very often, if at all. Right now, some of you math people that are better with math than me, right? I don't know. You might be able to kind of rework some of this logic to be even better than this. But you're at 5 prevents that, right? But there's a middle ground here where maybe I can do 8 versus 10. Run that. Right now we start to see some desert. Right. The other option I have at my disposal is instead of having desert be right 19 to 0 and 100 to 81, right? I can go into my data table, tile val terrain, right? I can make all these desert and all these desert, right? Or something like that, right? I can make desert more likely. Well, likely isn't the right word, but higher up, closer to 50. So they're less extreme, and then they generate more often, right? So that's all decisions you can make and how you want to customize this. But yeah, that's the core of this, right? I moved it back to 10. So I've got a couple more things to go through that are completely optional add-ons. So if you got what you wanted from this, feel free to go off. But I have 2 more pieces that I've implemented into my build that I like. The first is this recalc. So the recalc is the exact same as the initial calc, but now it's taking in more adjacents, and it is actually looking at every tile around itself, not just up and to the left. The reason that didn't work the first time was because we are creating this top down, left to right. But after we run it, everything's created. So what I do is I basically recalculate it all a second time. what it really does, what it accomplishes, is just a little bit more of a smoother feel. So I'm just going to bring this up before I assign my terrain. So I'll just run this a couple times again, right? So you can see it, it's things are bunched up, but it's still right, somewhat sporadic. And I could adjust my min-max if I want to. Or with this recalc, right, it makes things just a little bit more uniform, a little less crazy, right? Maybe this one not quite as much, right? But it just kind of helps things group again because we're running through it again. We're taking a bigger sample size for our average. And holding it together. I also have a smaller range in this too to prevent some of the um, to minimize the variation a little bit more. So uh, so yeah, let's go through it. I'll show you how I built it. I just want to look at one thing. The 10 information here. 10. Okay. So the way this recalc works, right? You can just duplicate this calc terrain value. So let's just do it. Pull this back down to here. Okay. So we can duplicate our calc, and I'm just going to call it recalc. And I'm going to add this off screen. Okay. So all of the logic is the exact same except for our adjacents. And for this, how many do we need? We need 8. So click this add pin 5 more times. So you should have, it starts at 0, so you should have a 7, right? A count of 8. Right, so this is 1 up, this is 1 to the left, this is 1 up, and then 1 to the left. What I now want to get when we come back in here, right? If this is the tile we're talking about, actually, let me go down to here, right? If we're calcing on tile 809, we're already getting 808, we're getting 708, we're getting 709. Now I want to get 710, 810, right? I want to get these other ones, right? So 810 would just be a +1, right? This would be a minus 99 because minus 100 takes me here, right? And I don't need to go quite that far. So minus 99, minus 1. This would be plus 100 to get this one. This would be plus 99. This would be plus 101, right? Hopefully you're following me. Again, my map is 100 by 100. So pretty simple to do. So let's just come off this, which is our tile ID, and let's do a add, and we will do an add 1 to get the tile below us. We will do an add 99 to get the tile over 1 and up 1. We'll do an add 100 to get the tile to the left of us. And we'll do an add 101 to get the tile above us. Or not above us, down 1, over 1. Now, like this, implementing this in, right, it gives you a smoother feel, which I like. But, right, it takes longer to generate. Now, this is going really quick still for us, but if you have a really huge map, it'll take longer to generate. But it's still a one-time generation. So, that is what is nice about this is really you don't care how long it takes to load because once it loads or creates, it's done. Maybe you care a little bit, but like RimWorld, when I play RimWorld, at least initially, I haven't played in a while, but um, that initial kind of world calculation, I mean, it could take a couple minutes sometimes, depending on the size. So um, that's fine. This. Okay. And then we want to, so we want to find it, break the structure, uh, get our generated value, and then just plug all of these into our array. Oh, what am I missing? this would be below. Oh, what I'm missing here. Obviously, I only have 7, but I should have 8. 99, 100, 101. Minus 99. What would minus? Sorry. This tile. I'm not getting this tile yet. This is minus 99. So just come off our tile ID, minus, not min, subtract 99. There. So now we're getting the average of all around it. And then what I do in here is instead of a 10, I even scale this down just a little bit more. I just do a 5, just to make it even smoother. Right, so we're still doing, right, so this is more of a more random, right, more sporadic. I mean, it's not crazy, it's a 10. But then we do this recalc, which just kind of smooths things out a little bit, if you want to think it that way, about it that way. So now let's plug this in. Calc 1, run it. And you should start seeing some better uniformity. Right, so I've got some random stuff, but it's not too crazy. Right, but it's different every time, right? So you're still getting a good random calc, which I like. Okay, then the last piece I have in this tutorial is I have this adjust terrain function. So what I don't know, what I don't really like is, right, just these like random, right, there's these random water tiles. Right, like here's a random forest tile. It was most annoying with the desert, right, just because the tile color was, you know, so much different that it stood out really bad. But just see, yeah, right here, exactly what I'm talking about, right? Like, I don't like these tiles being here like this, right? It just, I mean, obviously I'm not going for realism with with this game look. I'm going for something simple, a little retro, um, but it just doesn't make sense, right? So what this logic does, and we'll build this out, is again we're getting some adjacent tiles, and we're saying, well, is the tile type um, of the tile we're looking at, does it equal any of the tiles adjacent to it? Right? Do any of the tiles next to this tile equal the same tile type? If they don't, right, meaning this tile is its own type and it's surrounded by all different types of tiles, then let's recalc it to something else. And I'm recalcing it to the average of the other tiles. So if it's surrounded by forest, it'll recalc to a forest. Surrounded by grassland, it'll recalc to grassland. If it's surrounded by some desert, some grassland, it'll take the average and then recalc, and it might be either or. But it just makes more sense if it's this random, weird standalone tile. So just to maybe show this in practice quick before we build it out, and then you can decide if you care. It'll go in between our assigned terrain and then our add tiles. Right, so now you can see there's less. Now, there are still some, and honestly, I don't know why. I gotta dig into it more. Right, this random water, like, this should be getting snuffed out. These two really shouldn't be here because the adjacents are getting here. So there's some improvements to this logic, but by and large, right, this is a much better improvement over eliminating some of the randomness. Still persists, but it's better. So Let's build it. I'm just going to take this and bring it back down into my original, and I'll rebuild it with you guys. Just terrain, move off screen. Okay. So let's do new function, and I'm just going to call this just terrain. 1. And right off the bat, let's get this added in. And in our side terrain, yeah, just double check you got that return node. Okay. So first thing we got to do, let's bring in our tile map. Values. And for each loop, put that in. We can break this. Before I forget, I'm just going to do the return node here. Not that. Return node. What we need out of here would be tile ID, generated, and tile type. Like always, we only care about the tiles. Let's do a branch. And actually, before this, do a not boolean. We only care about the tiles that we have not calculated for. Well, really, we've calculated it. We care about the tiles that we don't have in the override table. Generated is probably a bad term for what this actually means. But whatever. Okay, so first, let's start by getting our adjacents. I'm actually going to improve the code I have and exist currently. Well, I think. What I'm doing right now is I'm grabbing this tile. If we're talking about 809, I'm grabbing this tile, I'm grabbing this tile, I'm grabbing this tile. And I see what I did. I'm grabbing this tile, which obviously I don't want. I meant to get this one. Okay, so that's why I had those random ones. Good thing we're doing this. So switching my side. Okay, so I'm gonna do that exact same thing because that should fix the problem I was having where we're still having some random one-offs. So come off this and let's do a subtract. And I want to subtract by 100. I'm going to do a reroute node. I want to subtract by 1. Again, this is to get our adjacents. So this will get 1 to the left. This will get 1 above. Now let's do add. Operations add. We'll do 100. So get 1 to the right. And then we'll do 1 to get 1 below us. And then we want our tile map, and we want to find, boom, boom, and then we can break this structure, grab our generated value and our tile type. Just copy and paste this a couple times. Boom. Okay, so first check I want to do is come off our tile type and do equal equal, and make sure you're doing this equal with in parentheses enumeration. So what I want to check is, are any of these adjacent tiles equal to in terrain type the tile we're running this for? So we've got to do this 4 times. 1 for each of our adjacent tiles. This, this, and this. And then connect each of these into one of the 4. Okay. Now we don't need to do 4 branches. What we can do is come off this and do an OR Boolean. Add 4 pins. So this will return true if any of these are true. And it will return false only if all of these are false. So let's do a branch. Let's come off this true and then plug this in. So we will come off this true logic only if one of these tiles is equal to our tile, terrain type. Which is good. That means that there's an adjacent tile that is of the same type of it. So we're actually going to build our logic off the false. Conversely, you could do a not Boolean, and then the true, um, whatever. So if this is true, this means that this tile is just by itself, right? And we don't want, this tile to be by itself of its own type. So I want to change its type. So how do we decide what to change it to? So what I'm going to do is really kind of copy some of the logic we have in our calc. So let's call this generated value. Let's make an array. Add 4 pins, or add 3 pins. So you have 4 pins. Plug this in, plug this in, plus plug this in. Come off this. Average of the int array. Round this. Do not truncate. Round this. Now I do one more check, right? So for me, 50 is water. If this average is 50, I don't want it to be water, right? Because I just don't want these random water squares. So what I'm going to do here is I'm going to do, does this equal 50? Because 50 is my water. Now, if you have a range of water, like water is, I don't know, 49, 50, and 51, you might have to do something different than this. You can probably check the enumeration, which I'll show you. Just follow along with me for now. So let's pretend you're doing 50. If not, I'll explain what you can do. So if it equals 50, I don't want it to be 50. But the average is 50, so that's why we're getting 50. So what we do is we can right click and do a select int. And we did this before, plug this in. So if this is true, then be A. And I just make A 51, right? Because 51 is not water for me. I think it's a forest. I guess we can look quick. Yeah, 51 forest. And for me, I want forest to be my most common tile because I want a lot of trees and stuff. So I'm doing 51. If it's not equal to 50, then it will be B, which will just be whatever the heck the average was. So good to go there. And then what we do coming off of this is grab our terrain map and find, and then do this, right? And then this returns our tile type. What you could do instead of this is after this round, you could just find, and then you could come off this and then check, does this equal, not that equal num? Does this equal water? And then if true, right, then change it to something else, right? So if you want to do it that way, that's one way you can get around it. If 50 isn't your water, or, well, if your water really eclipses more of a range, right? You could do like, is it greater than this and less than this? There's a couple ways to do it. So, okay. So now we would have what this new terrain would be, and we need to set it. So let's grab our tile map and do a get, or not get, find, and grab this tile ID. Just gonna put a reroute node here. Let's bring this all the way over. Let's do set members, and we want to set the gen value and the tile type. And this would only be off the true. So then we will plug in this return value into the gen value and this terrain type into the enumeration. And then we just need to add it back into our map. So grab tile map, do an add, plug this in. This is our tile ID. Grab this and this, and then pass our structure through. And let's make sure we have the return node. Let's make sure this is plugged into our logic, which it is. Run it. Why is there water? Man, it works for It's this random desert here, random grass here, a lot of random water. 50 is water. Assign tile, adjust tile. Let me just look through this quick. If it's not generated, this will be one to the left. This would be one above. This would be one to the right. This would be one below. All in. If any of these are true, wait a minute. I think I actually want this. Yeah. Shoot. This should come out the false, not the true. Sorry. If any of these are true, then this will be true. But we care about the things that are false. So, okay. Whew, I was like, man, what the heck? um, okay. So, yeah, make sure you switch this over to the false. Awesome. Right? So much better. We still have some water, right? But it's all water by water, which I like. No, I think I haven't tried this yet, but like you could then recalc this again, right? And I think that would kind of continue to smooth things a little bit. You can also adjust your mins maxes, and you can also adjust, what your lookups are, right, to get more desired outcomes. Like the water, I don't know. I don't know what to do with the water in my gen because I want there to be some water. I don't want it to be super common. Um, but I don't really like this at all, right? Like this 4 box, I don't mind. But these little weird 2 ones, I don't know. I don't really like. I'd like there to be a lake. Um, I don't know. I don't really know the best way to do it, but I've got all the tools now to kind of tweak with this, right? I can do maybe another iteration. I can scale the range of the water a little bit if I want it more common. So yeah, that's all I got for this tutorial. Hopefully this made sense. If you're stuck, hit me up on the Discord, link in the description. It's the best place to get help. What I will be doing next, if you want to see it, let me know in the comment section, is, right, like I said, it's going to be kind of like a RimWorld Factoria type game. So these are my different resources: copper, tin, coal, iron, silver, gold, diamond. I forget what I'm calling this, but it's kind of a made up fantasy resource. Um, these will then spawn over the top of some of these tiles as a it'll be its own static mesh. Well, actually, these will be actors, but it'll just set right on top of it. So if you want to kind of see how I'm going to do that, let me know below. And once I figure out how I'm going to do that, I'll make a video on that as a part 2 to this. It's going to be similar though, right? I mean, it's going to be probability based on if it occurs or if it's not, if it doesn't. But the first thing I got to decide is like the starting point, which I probably have the starting point always just be the same, at least to start with this project, right? So maybe here. And then what I'm going to do is like I'll have basically a heat map going from start point over, where the more rare resources will be over here, and the less valuable resources would be more likely over here. So maybe the first part is kind of like the quality determination, which that will be static. Basically, I think what I'll do is every tile will have a quality number assigned to it, and then it'll be procedural and random on if and or spawns on a tile, and then based off the quality of that tile, that will determine the probability of each of these types of ores. Now, I don't know exactly how I'm going to do that yet, but I think I've got a good theory in place for it. And then I'll probably try to do some logic where it's like, yeah, well, it's not just one coal, maybe, right? If there's a coal next to it, it'll be more likely there's another one, so you can kind of have little clusters. So, yeah, that'll be next for me. So, if you're curious in seeing that, once I figure it out, just let me know. But yeah, thanks for watching. Again, hope you're able to follow along. If you weren't, just let me know in the Discord. I'll help you out. But yeah, this was a fun one. I was looking up online trying to find, you know, resources to do this, different tutorial videos, and I couldn't find any. So then I just went to the drawing board and came up with this, and it works pretty well for my purposes. So just wanted to share what I created. So yeah, thanks for watching.